Hello everybody, welcome into another lesson. So today we are starting the last of the two units which both belong to trigonometry. So now we are on the trigonometry side of the course. And today's going to be very much an introduction to right triangle trigonometry, which some of this is going to largely seem like a review from geometry when we introduced it. So I'm sure some of you probably remember the saying SOHCAHTOA, that acronym SOHCAHTOA. Well, here you have your right triangle. You have an angle theta. That's what that symbol's called, theta from Greek. That's the angle you're referring to. Opposite the angles, well, the opposite leg, you have the adjacent leg, and then you have the hypotenuse of the right triangle. So SOHCAHTOA, the SO part stands for sine, which I have the abbreviation next to each of these. Sine is always, the sine of the angle equals the opposite leg over the hypotenuse. So opposite over hypotenuse is the sine. Then you have your cosine, which is the abbreviation here, the cosine of the angle. That's the adjacent over the hypotenuse. Then you have the tangent. Here's the abbreviation for tangent next to it. It's the opposite leg over the adjacent leg is the value of the tangent. So those are three functions you probably might already know from geometry: sine, cosine, and tangent. What we didn't talk about in geometry was the fact that there are three more trig functions that are simply reciprocals of sine, cosine, and tangent. And I wrote them next to their respective functions that they're reciprocals of. So the reciprocal of the sine function is called the cosecant function. And here's the abbreviation for cosecant. So it's the hypotenuse over the opposite leg, and it's the reciprocal of the sine function. Then you have the secant function. Here's the abbreviation for that. It's the hypotenuse over the adjacent leg for the angle. It's the reciprocal of the cosine. Then you have the cotangent function. Here's the abbreviation for that. It's the adjacent leg over the opposite leg, and it's the reciprocal of the tangent function. So those are all 6 trig functions now that we've learned. So we're going to do some practice examples today. So we're going to start out with some examples here. We're going to find the value of the 6 trig functions for each of the triangles we're doing. All right, so first triangle has one leg has a length of 5, the other leg has a length of 10. We don't know the length of the hypotenuse. We'll call that C. Well, we want to find the value of the 6 trig functions, but remember, we don't know the length of the hypotenuse. It's time for good old Pythagorean Theorem. Pythagorean Theorem was C squared equals A squared plus B squared. So C squared would equal your A. We'll make that 5. That would be 5 squared plus the 10 squared. So that would equal 25 plus 100, which means your C squared would have to equal 125. So to find C, you'll end up taking the square root of 125, which would break down into the square root of 25 times 5. So that means C would equal 5 times the square root of 5. And since we're evaluating a length, we are only concerned with the positive square root because you can't have a negative length. So now we know that C is 5 times the square root of 5. So let's go ahead and write that up here for the hypotenuse. All right. So let's find the value of the 6 trig functions. Your sine of theta, again, that's the opposite over the hypotenuse. So opposite of theta is 5. That would be over the hypotenuse of 5 times the square root of 5, which we know the 5's will cancel out. This would equal 1 over the square root of 5. Now rationalize your denominator. This would be times the square root of 5 over the square root of 5. Then giving you that your sine is equal to the square root of 5 over 5. So the sine equals the square root of 5 over 5. Now, what about your cosine of theta? The cosine of theta, of course, is your adjacent over your hypotenuse. So the adjacent leg is 10. That'll be 10 over 5 times the square root of 5. Well, the 5 goes into 10. This will turn into 2 over the square root of 5. So go ahead and rationalize your denominator. This will be times the square root of 5 over the square root of 5, giving you your value for the cosine of theta to be 2 times the square root of 5 over 5. So there's your cosine. Now what about your tangent? Your tangent of theta is simply, that's the opposite over the hypotenuse, which would be equal to, I'm sorry, it's opposite over adjacent. I don't know why I did that. That was sine. Opposite over adjacent is tangent. That's going to be 5 over 10, which would turn into 1/2. So the tangent is equal to 1/2. Now why don't we go for cosecant? Let's find the cosecant of theta. It's the reciprocal of the sine, so reciprocal of opposite over hypotenuse is hypotenuse over opposite. So that's the hypotenuse over the opposite side. Well, the hypotenuse is 5 times the square root of 5. Divide it by the opposite 5. Divide it by the opposite side, which is 5. Your value for the cosecant is simply the square root of 5. That's what you get for the cosecant, the square root of 5. Now let's find the secant of theta. Secant of theta is the reciprocal of the cosine. Your cosine's adjacent over hypotenuse, so this would be hypotenuse over adjacent. So the hypotenuse is 5 times the square root of 5 over 10 for your adjacent. That would give you square root of 5 over 2 for your secant of theta. And then last but not least, let's find the tangent of theta, the cotangent of theta. So the cotangent of theta, well, it's the reciprocal of the tangent of theta. Your tangent's opposite over adjacent, so cotangent would have to be adjacent over opposite. All right, so the adjacent to theta is 10. The opposite side is 5. So your cotangent of theta is simply 2. So you should get a sine of the square root of 5 over 5, a cosine of 2 times the square root of 5 over 5, a tangent of 1/2, a cosecant of the square root of 5, a secant of the square root of 5 over 2, and then a cotangent of 2. And I got more where this came from. We're going to change some values up here. So yes, whenever you have radicals in the denominator, remember to rationalize your denominator so it's in proper form. All right, so We have the shorter leg is 9, longer leg is 12. Again, we don't know the hypotenuse, so let's call that C. So let's do Pythagorean Theorem to find the length of our hypotenuse. So C squared, that's A squared plus B squared, so that would turn into 9 squared plus 12 squared, which would equal 81 plus 144, which means C squared equals 225. Well, the square root of 225 is 15. So C is going to equal 15. Now we know the length of the hypotenuse to be 15. All right, so we can go ahead now and find the value of our 6 trigonometric functions. So the sine of theta, of course, is going to be your opposite side of 9 over your hypotenuse of 15. 9 over 15 simplified would be 3/5. So the sine of theta would be 3/5. Then we got to deal with the cosine of theta. That's the adjacent, which would be 12 over your hypotenuse, which is 15. So what is 12 divided by 15 simplified? That would be 4 over 5. So the cosine is 4 over 5. Now let's find the tangent of theta. The tangent of theta is the opposite over the adjacent, so that would be 9 over 12. So what's 9 over 12 simplified? Well, that's 3 over 4. All right, now, if you know the values of your sine, cosine, and tangent, there's another way to approach the secant, cosecant, and cotangent. Let's find cosecant of theta. Whoops, I almost forgot a letter in that. Because we remember cosecant of theta is simply the reciprocal of the sine of theta, right? Well, that's going to equal, in this case, 1 over 3/5, right? When you have a fraction of the denominator, you just invert it. This would turn into 5/3. So the cosecant of theta would be 5/3, since it's just the reciprocal of sine. Then we can find the secant of theta relatively easy also, because the secant function is simply the reciprocal of the cosine. So 1 divided by the cosine of theta, well, that's 1 over 4/5, which would give you 5/4 for your secant. So the secant of theta is going to be 5/4, and then your cotangent of theta, well, again, cotangent is simply the reciprocal of the tangent function, so 1 divided by the tangent of theta, which in this case would be 1 divided by 3/4, which should give you a value of 4/3. So the cotangent of theta would be 4/3. So here you have the 6 values of your trig functions. 4 more like this, and then we're going to really throw back to geometry here for a few exercises. All right. We have another triangle. This time we got a hypotenuse of length 18. The shorter leg is length 10. We don't know the length of the longer leg. We'll call that side B. It's true that C squared equals A squared plus B squared, right? This time we know C, that's 18, which would be squared. C squared equals A squared, which in this case is 10 squared, plus your B squared. So let's figure out what the heck 18 squared is. I want to say it's 324, but let's make sure. I don't want to get that wrong. I was right, it's 324. So that means 324 would equal 100 plus b squared. So b squared equals 224. Let's see what 224 could potentially break down into. Well, good news, it breaks down into the square root of 16 times 14. Square root of 16 is 4, and then you just have times the square root of 14. So that's the square root of 224, so that means side B has a length of 4 times the square root of 14. Alright, so now we know all the sides, we can go ahead and find the values of the 6 trigonometric functions. So take the sine of theta, let's find that. That always equals your opposite side, which in this case is 10 over the hypotenuse, 18, which reduced should give you 5/9. So the sine of theta is 5/9, and since we know the cosecant's the reciprocal of sine, why don't we find that? The cosecant of theta equals the reciprocal of the sine of theta. The reciprocal of 5/9 is 9/5. So that's actually probably a good way to approach this, is take the reciprocal function right away. Alright, now let's go ahead and do the cosine of theta, which equals your adjacent over the hypotenuse. So that would be 4 times the square root of 14 divided by 18, which should reduce into 2 times the square root of 14 all over 9. So there's your cosine of theta, 2 times the square root of 14 over 9, which means let's deal with the reciprocal of cosine, which is secant. So let's go for the secant of theta. So the reciprocal of 2 times the square root of 14 over 9 would turn into 9 all over 2 times the square root of 14, which means we want to rationalize our denominator, so multiply by the square root of 14, which would turn into 9 times the square root of 14 all over 2 times 14, which would be 28. And really, we can't simplify this any further. So the secant of theta is going to be 9 times the square root of 14 over 28. And then last but not least, we have 2 more. We have the tangent of theta, which equals your opposite over your adjacent. So this will be 10 all over 4 times the square root of 14, which, why don't we go ahead and rationalize that denominator. So this will be times the square root of 14 over the square root of 14, which would then end up equaling 10 times the square root of 14 all over 4 times 14, which would end up being 56. Well, okay, so the 10 and 56 will break down further into 5 times the square root of 14 all over 28. So the tangent of theta would be 5 times the square root of 14 all over 28. Which means now we can find the cotangent of theta, since that's the reciprocal of your tangent. So this would turn into 28 over 5 times the square root of 14. Now let's rationalize that denominator. So this would be times the square root of 14 all over the square root of 14. So that's going to equal 28 times the square root of 14 all over 5 times 14. Well, what do we know? 28 and 14 factor into each other. This would turn into 2 times the square root of 14 all over 5. That would be the value of your cotangent of theta, 2 times the square root of 14 over 5. Alright. 3 more like this, then we're going to do a few special right triangles, which will probably bring back some memories from geometry also. I don't know why I erased the triangle. I did not mean to do that. Let me draw this a little bit bigger so you can see the scale of them, so you can see it. Here's theta, 13, 4. And again, we don't know this side. Okay, so we have another right triangle with, we don't know the length of B, the longer leg. We know the shorter leg has length of 4, the hypotenuse has length of 13. Well, let's use the Pythagorean Theorem to find our longer leg. So this would mean that 13 squared would then equal 4 squared plus B squared. So this means 169 equals 16 plus B squared. So that means then that B squared equals 153, which I don't think 153 breaks down, but I could be wrong on that. I would like to make, well, wait a second. 51, so let's see. I was wrong, it does break down. It breaks down into the square root of 9 times 17, which means B is going to equal 3 times the square root of 17. So now we know the length of the longer leg, that's actually 3 times the square root of 17. So we can now proceed to find the value of our 6 trigonometric functions for this right triangle. So let's find the sine of theta in this case. The sine of theta equals your opposite side of 4 over your hypotenuse of 13. And we can't reduce it any further, so the sine is 4 over 13, which means let's deal with our reciprocal function of sine, which is the cosecant. The cosecant of theta equals the reciprocal of 4/13, which would be 13/4. That's your cosecant, would be 13/4. Alright, now let's deal with the cosine of theta. Cosine equals your adjacent leg of 3 times the square root of 17 all over your hypotenuse, which is 13. So there's your cosine. Now we can deal with the secant, which is the reciprocal of the cosine. So secant of theta, this would turn into 13 all over 3 times the square root of 17. Now rationalize your denominator, so take times the square root of 17 all over the square root of 17. You'll end up with 13 times the square root of 17 all over 51, and it doesn't factor any further. So your secant of theta would be 13 times the square root of 17 all over 51. All right, let's find the tangent. The tangent of theta equals the opposite side of 4 all over the adjacent side of 3 times the square root of 17. So go ahead, again, rationalize your denominator. So times the square root of 17 over the square root of 17. This is going to simply equal 4 times the square root of 17 all over 51. So the tangent of theta is 4 times the square root of 17 over 51, which means now we can find the cotangent of theta. And if you want, you can do the reciprocal of the tangent of theta, which means you'll have to rationalize again, or you can just know that it's simply the adjacent side over the opposite side. So that would give you 3 times the square root of 17 all over 4 for your cotangent of theta. So it helps to know how to do it both ways. If you just look at the triangle and know it's the adjacent over the opposite for the cotangent, or you could take the approach that it's the reciprocal of the value of the tangent. Either way. 2 more of these, then we got the special right triangles we're going to talk about. Let's see what we're given here. So we got 9 and 25. Okay. And again, we don't know the length of the longer leg. So we have another right triangle. We don't know the length of the longer leg. The length of the shorter leg is 9. The length of the hypotenuse is 25. So let's use Pythagorean Theorem to figure this out. So this means that 25 squared is going to then equal that 9 squared plus b squared. So that means 625 would equal 81 plus b squared, which should then mean that b squared equals 544. Now let's see if 544 breaks down any further. Yes, it does. It breaks down into the square root of 16 times 34, which means b would be equal to 4 times the square root of 34. So your longer leg has a length of 4 times the square root of 34. Alright, so now we know the length of all of our legs. Let's go ahead and find the value of the 6 trigonometric functions. So the sine of theta would equal the opposite side of 9 over the hypotenuse of 25, and that won't reduce any further. So sine is 9 over 25, which means now let's go ahead and look at our reciprocal of that, which is the cosecant of theta. Cosecant is the reciprocal of 9 over 25, so it would be 25 over 9. So the cosecant equals 25 over 9. Now let's find the cosine of theta. That's going to equal your adjacent side of 4 times the square root of 34 all over the hypotenuse of 25. So the cosine of theta equals 4 times the square root of 34 over 25. Now let's find the reciprocal of the cosine, which would be the secant of theta. So the secant of theta is going to then equal the reciprocal of your cosine, so that would be 25 all over 4 times the square root of 34. Well, let's go ahead and rationalize the denominator. So this turns into 25 times the square root of 34 all over 4 times 34, which is going to be 136. So the secant of theta equals 25 times the square root of 34 over 136. All right, now let's find the tangent of theta. The tangent of theta equals the opposite side of 9 over your adjacent side of 4 times the square root of 34. So again, let's go ahead and rationalize the denominator. So times the square root of 34 over the square root of 34. So this would turn into 9 times the square root of 34 all over 136. And let me see if any of this breaks down. If the 9 and 136 can somehow simplify. Nope, they do not simplify. So your tangent will be 9 times the square root of 34 over 136. And then last but not least, let's find the cotangent of theta. So the cotangent, well, you can also look at this as your adjacent over your opposite. So that would just be 4 times the square root of 34 divided by 9. That would be the value of the cotangent of theta, 4 times the square root of 34 over 9. One more like this, then we move on to special triangles. Alright, so we have another right triangle, short leg length of 6, or one leg I should say length of 6, the other leg length of b, hypotenuse length of the square root of 85. So let's use Pythagorean Theorem to find b. So this means we'll take that square root of 85 to the second power, set it equal to 6 to the second power plus b squared, which would then mean that 85 equals 36 plus b squared. So that means b squared is then going to equal 49. Well, square root of 49 is 7. So we actually got a whole number there. So we know the length of the longer leg is 7. So now that we have all the lengths we need, let's go ahead and find the value of the 6 trig functions. So sine of theta equals your opposite side of 6 all over the hypotenuse of the square root of 85, which we'll want to rationalize the denominator. So this would just simply turn into 6 times the square root of 85 all over 85 for the value of the sine of theta. Now the reciprocal, the cosecant, it might be easier, instead of trying to do the reciprocal and rationalize yet again, we can also know the cosecant is the hypotenuse over the opposite, which would just simply give you the square root of 85 over 6. So the value of the cosecant is the square root of 85 over 6. Now let's find the cosine of theta. The cosine of theta equals your adjacent leg of 7 over your hypotenuse of the square root of 85. Then we'll rationalize the denominator yet again. Which would just turn this into 7 times the square root of 85 all over 85. And then, of course, we'll deal with the reciprocal function, the secant of theta. Which, it might be easier again to just know that the secant is the hypotenuse over the adjacent side. So that would give you the square root of 85 all over 7. You could do the reciprocal if you want and have to rationalize again. I mean, you would get the same answer, but sometimes it's just quicker to know the ratio of each of these functions. Now, last but not least, we'll do the tangent and cotangent. So tangent of theta equals your opposite side of 6 over your adjacent side of 7. That one was easy enough. You get 6 over 7 for your tangent. And then we can do the cotangent of theta. We know that's the reciprocal of tangent, so the reciprocal of 6/7 would be 7/6. So the cotangent of theta is 7 over 6. All right. So that wasn't bad at all. Now, there are two special types of right triangles from geometry. And I remember in geometry and at the beginning of this course mentioning that they're going to come up all the time from here on out. The first one we have is our 45-45-90 right triangle. This starting to ring a bell? 45-45-90. Where in general, the lengths of the 45-45-90 triangle, the two legs have the exact same length. We'll just call those length 1. But the hypotenuse is always the square root of 2 times as long as one of the legs. So we have here then the hypotenuse is always the square root of 2 times longer than one of the legs of a 45-45-90 triangle. All right, so let's do a few exercises here. So one leg of the 45, 45, 90 triangle has a length of 7. We need to find the length of the other two legs. So what is, of course, the other angle is also 45, which means the other leg has to have a length of 7. Now, what would be the length of the hypotenuse? We remember the hypotenuse is always the square root of 2 times as long as the length of one of your legs, so the hypotenuse would have a length of 7 times the square root of 2. Easy enough, right? Now, what if I had across from one 45-degree angle, you have a length of the square root of 2. So the length of one of your legs is the square root of 2. Well, since it's a 45, 45, 90, that means your other leg has to have a length of the square root of 2. Now, the hypotenuse is always the square root of 2 times as long as one of the legs, right? So the square root of 2 times the square root of 2 would just give you 2. So your hypotenuse in this case will be 2. Now, let's do one more with this triangle. We're only given the hypotenuse. We need to find the lengths of sides x and y. Well, what do we know for a fact? It's a 45, 45, 90 triangle. We got the length of the hypotenuse, but in a 45, 45, 90 right triangle, the two legs are equal to each other, right? So that means x equals y. So let's find x. X would equal that length of the hypotenuse of the square root of 11. So that means then, because the hypotenuse is always the square root of 2 times longer than a leg, that means that a leg would have to be the hypotenuse divided by the square root of 2, wouldn't it? So now we just rationalize the denominator, and you'll end up getting that x equals the square root of 22 divided by 2, which actually also equals y, since it's a 45, 45, 90 right triangle. So you get x and y both equal the square root of 22 over 2. Now there's one more type of right triangle, and I guarantee probably most of you already know it, but I'm going to do it anyway. And if you said 30, 60, 90, you'd be 100% right. So there's also the 30, 60, 90 right triangle. In general, the shortest leg for a 30, 60, 90 right triangle is across from the 30-degree angle. We'll call that length 1 for an arbitrary unit. So the side opposite the 60-degree angle, the longer leg is the square root of 3 times as long as the shorter leg. And then the hypotenuse, which is across from the 90-degree angle, is twice as long as the shortest legs. Twice as long as the shortest leg. So the 30-degree angle, the side opposite that is going to be the shortest leg. In this case 1. The side opposite 60 degrees will be the longest leg. It's the square root of 3 times as long as the shortest leg. And then your hypotenuse is twice as long as the shortest leg. So let's do some examples here with this. Let's say in this case, I'll make 30 again, length of 7. Let's find x and y. Alright, so we know that the side across from the 30-degree angle is going to be 7. Let's find x, which is the length of the longer leg across from 60. Well, x is going to equal what? that always equals the square root of 3 times the shorter leg, so that would be 7 times the square root of 3. So we found the length of x across from the 60-degree angle. Now y, the hypotenuse, is always twice as long as the shortest leg, so 2 times 7 means your hypotenuse would have a length of 14. So that gives you a hypotenuse of length 14. All right. Now, let's change gears again. Alright, so it's a little bit of reversey here. We don't know the length of the longest leg, which is across from the 30-degree angle. We don't even know the hypotenuse, but we do know the length of the longest leg, which is 9, right? Well, let's find the hypotenuse. No, let's not find the hypotenuse. Let's find the length of the shorter leg first. So isn't it true that 9... the length of your longer leg is always equal to, it's a square root of 3 times your shorter leg, which is y. So that means y is going to equal 9 divided by the square root of 3. Now rationalize your denominator. So this is going to turn into 9 times the square root of 3 over 3, or simply just the square root of 3. So your shorter leg has a length of the square root of 3. Oh, 3 times the square root of 3, excuse me. I don't know what I was thinking. That's 3 times the square root of 3. Forgive me for that, because 3 divides into 9 3 times. So your shorter leg has a length of 3 times the square root of 3. Now, y was your shorter leg, so that means x would equal twice your shorter leg, right? Which in this case would be 2 times 3 times the square root of 3, which means your hypotenuse has a length of 6 times the square root of 3. So there's that one. I got one more. Kind of like this, but a little bit different. Alright, so the longer leg has a length of 14. Hypotenuse length x, shorter leg length y. So a very similar example, only different numbers. So we don't know the length of the shorter leg, which is y. We don't know the length of the hypotenuse, which is x, but we know the length of the longer leg, which is 14. Well, again, the length of your longer leg, in this case 14, always equals the length of your shorter leg, which is y, times the square root of 3, right? So let's solve for y. You'll divide both sides by the square root of 3. So y would equal 14 divided by the square root of 3. So rationalize your denominator, which would have to mean then that y equals 14 times the square root of 3 over 3. That would end up being the length of your shorter leg, 14 times the square root of 3 all over 3. Now, it's also true then that your hypotenuse, which is length x, is always equal to twice the length of the shorter leg, which is y. So x would equal 2y, which means it's going to equal 2 times that 14 times the square root of 3 over 3, which means the length of your hypotenuse would then be 28 times the square root of 3 all over 3. So this has just basically been a review of a lot of geometry. The only new stuff we did was the secant, cosecant, and cotangent. But if you can just remember that those are just reciprocals of sine, cosine, and tangent, you'll be just fine. So in the next lesson, we'll continue this with calculating some trig values and even solving some right triangles for missing values that are other types of angles. We'll solve for missing angles, and we'll actually calculate trigonometric values for other types of angles. So I hope everyone has a great day. Take care.